One tension that one sometimes sees in mathematics, or maybe dichotomy is a better word, is structure and explicit problems. So combinatorics has a lot of the latter and is gaining more of the former, some theory of the structures that arise. Do you see yourself anywhere in the pole of what you sort of like most?
Well, one of the themes coming out, and I guess in some sense the regularity lemma kind of typifies that, is that large structures often are composed of something that's pretty well structured, and what's left over is pretty random, and then there's a little noise at the end. And so in one of the themes in Ramsey theory is that complete disorder is impossible. And I heard a saying from a lawyer recently that says, complete disorder is inevitable if you have a lot of lawyers together. But it's a very nice idea that something looks really complicated, actually inside there's some very well-structured thing going on. And instead of that, something even more well-structured. And it's just that you don't see it. I mean, there's a nice example. There's a certain recurrence that says if you know xn, I'll tell you how to get xn plus 1. It's kind of a simple thing. And it turns out if you take this sequence, it's a sequence of zeros and ones. It just looks pretty random. It came up in some sorting algorithm. Somebody from the labs, well, can you say what's going on here? And you look at it. And it turns out that after you think about it for a while, look at it, I recognize the 1, 0, 1, 1, 0, 1, 0 as the binary expansion of the square root of 2. It was actually, now why I would recognize that, I don't know what I was thinking about, but once you see, oh, looks like that's what it is, not so hard to prove. So something that kind of looked random actually was very well structured. It's just that you didn't understand that until you... So I had this discussion with Steve Wolfram, who has this theme, there's certain cellular automata, certain rules for generating what happens at the next state given the local situation of the current state of each of these blocks on a big tape. He says, look, once it gets reasonably complicated, it's just kind of unpredictable, it's random. You'll know. I said, well, maybe it is a little more predictable, you just don't quite see what's going on.
It sounds like you're even really rejecting the dichotomy between concreteness and structure, namely they're both present.
So I always had the belief that somehow in mathematics, the probabilistic method is very powerful. And it says, look, you just look at all possible graphs, for example, where you flip a coin, put an edge in or not, and with very high probability, something happens, okay? And then you can use this argument to show something must happen, because the bad things, there's just not enough of them. But you don't know how to get a good thing. You can't actually construct a good thing. And I always felt that constructive methods are really, eventually will dominate. But now I'm not so sure. Not so sure, Not so sure. I mean, the fact that we're humans is really pretty limiting, I mean, we didn't evolve to understand the structure of the space-time continuum or view things 100,000 dimensions, whereas we know how to stay out of the rain and keep getting eaten by animals, but we're not really up to the job of, the Riemann hypothesis or something. I mean, there's a story, there was a race so advanced that they awarded a prize to the first mathematician who actually realized the Riemann hypothesis needed a proof. Isn't it just obvious? It's like the Jordan curve theorem. Well, I mean, you draw a simple closed curve in the plane, there's inside and outside, obviously, right? Well, not so easy to prove. Well, a race so advanced that, you mean that needs a proof? Come on. Well, so, I don't know, I think we've got a long way to go. I hope we get there, humans. But, I mean, the fact, back to astronomy, it looks now that most stars have planets. Seems to be the case. And our galaxy has about 100 billion stars. And there are about 100 billion galaxies that we know about. That's a lot of planets. Something's got to be going on. We're the only ones. As Carl Sagan, my classmate at Chicago, by the way, said, if so, it's an awful waste of space. Right. Yeah.